This brings us about to our halfway point, to a point around 2 million years ago. We've gotten through our Australopiths, the dominant hominin group, from 5 to 2 million years ago. I've stressed that like 4 times now, so it will also be a question on your study guide, so you can reasonably assume it's going to be a question on the next exam. We've got various species of early Homo that are known through the fossil record. We've got Homo rudolfensis, which dates back almost to 2 million years ago. We've got Homo habilis, Homo erectus, who represents the first member of our genus and really the whole hominin line to leave Africa. We've got Homo heidelbergensis. We've got archaic Homo sapiens that are collectively referred to as Neanderthals and Denisovans. So around 2 million years ago, we initially thought that, Homo habilis was one of the first fossils found by Louis Leakey in the Olduvai Gorge. So Louis Leakey at the time named Homo habilis that because it translates into quote unquote handyman. And the conventional thinking was that Homo habilis then was the first member of our genus, then evolved into Homo erectus, and then Homo erectus evolved into Homo sapiens. But as we've kind of unearthed more and more fossils of both Homo erectus and Homo habilis, it turns out these two are sister species. So there's likely someone else kind of sitting at that origin point for the genus Homo. Homo rudolfensis might be a likely character, dates to about 1.8, 1.9 million years ago. But what we do know is that by 1.9 million years ago, we've got the separation of Homo habilis and Homo erectus. Homo habilis had a very small body, very chimp-sized, with ape-like limb bones, really long arms, really long fingers. This implies that Homo habilis still needed to be able to climb trees. And so when we think about what the advantage would have been of retaining tree climbing, it's safety. Right? When we think about monkeys, even those like baboons that are found on the African savanna, when they're threatened, when they're predated upon, they try to find high places to climb because, fact of the matter is, lions and hyenas cannot climb trees. This also correspondingly represents perhaps a scavenging niche that hyenas, at the very least, couldn't utilize. That would be, there are many large cats who cache their kills in trees. I mean, and we've got leopards, jaguars, that kind, that do so. So being able to climb trees not only would have been an advantage to for safety at night to keep from being predated upon, but also could have been an avenue to get more scavenged game. And so these longer arms and kind of this ratio of arm length to leg length really indicates this tree climbing ability. The reason that we squarely place Homo habilis within the genus Homo, however, is that we've got a pretty significant jump in brain size. Homo habilis has a brain size of about 600 to 700 cubic centimeters. Homo habilis clearly uses Oldowan-style tools to be able to extract a little bit of meat from scavenged kills. So again, how do we know it's scavenging? Well, we look at the cut marks versus the tooth marks. There are other ways, though. We can look at the type of bones that are represented. Early hominins that are eating meat leave what are called faunal assemblages. This is the collection of animal bones that are discarded at a site when you're done eating them. And so when we look at the faunal assemblages of scavengers, we find a lot of what is called head and hoof. Think about a cow. Right? How much meat's going to be present in the head and the hoof? Well, the head, of course, is going to have the brain and the tongue, which both can have, a pretty big size. But aside from that, there's some meat on the cheeks, and that's it. The rest of the head doesn't have very much muscle attached to it. When we think about cow hooves, I mean, golly, we buy them for our dogs to chew on to kind of fulfill that gnawing need. So there really isn't a lot of meat that's present on the hooves of grazing animals. So head and hoof faunal assemblages represent scavenging. When we think about the cuts of meat that we want, we're talking about things that are from the rump and the thigh. And so we're talking about things that are associated with the femur. And so when we start to see faunal assemblages that have a large proportion of what we call long bones, femurs and such, now we're talking about active hunting. And so Homo habilis is associated with faunal assemblages that are mostly head and hoof that have tooth marks present on the bones before the cut marks that Homo habilis put in place. Dating back to about 1.8, 1.9 million years, we also have Homo erectus as a sister species of Homo habilis. Homo erectus has a fully modern postcranial skeleton. So if we were to put the fleshed out skeleton of a Homo erectus walking down the street, from the neck down, you wouldn't realize that it was a different species. It has limbs in proportions to ours. It has feet that have the big toe in line with the other toes and have a firmly established arch. They've got a pelvis that is fully modern. Everything about the postcranial skeleton of Homo erectus was fully modern. That means Homo erectus was really, really, really good at being able to basically jog, to travel these long distances at what we would consider an endurance pace. The skulls of Homo erectus still look a bit different. The cranial capacity is around 1,000 cubic centimeters. We start to see increased ossification and thicker bone at the base of the skull around the foramen magnum. Well, this is because suddenly growing a large brain is becoming a risky endeavor. With Homo erectus, we firmly have childhood. We've got young that are dependent upon their parents well up to about the age of 10 or so. And so why? Because they've got to have this long period of, or longer period of critical learning and brain growth. And so when you're going to grow a brain to 1,000 cubic centimeters and yet you only have a brain that's around 150 cubic centimeters when you're born, you've got this critical period of early development. Homo erectus also has smaller back teeth and larger incisors. The reason that Homo erectus starts to reverse the trend that we saw throughout the Australopiths of large molars that are thickly enameled is because Homo erectus could control fire. This is a really big cultural leap. What does controlling fire allow us to do? Well, it means suddenly we can pre-digest our food. A lot of what we were eating, we couldn't really process and get all the nutrients out. Think about changing a baby's diaper. If young children who are still diapered have eaten something like corn, generally they're not eating it on the cob, they're eating it off the cob. And you look at their poop when you change their diaper, that corn passes through the digestive tract basically untouched. It looks the same coming out as it looks going in. And so by cooking things, both plant material and meat, we make the nutrients more what we call bioavailable. That means that we can absorb more nutrients from the foods that we've procured. So cooking basically jumpstarts that process of digestion and means that we're able to get more bang for our buck, more nutrients from the same quantity of food. This also then reduces that selection pressure on the chewing apparatus, which means we can lessen both the musculature and the size of the jaw devoted to chewing, which means we can free up area in our skull to grow a bigger brain. So these are definitely interrelated. Homo erectus sees a jump in tool traditions from Oldowan tools, which are just this modified core, to Acheulean tools, which are more heavily retouched. You retouch from both sides. You're getting a sharper cutting edge and more of the tool then with this cutting edge. Homo erectus also left Africa. We've got Homo erectus fossils throughout the Middle East, throughout South Asia, and into Southeast Asia. Homo erectus also crossed areas that would have been permanent water crossings. And so how do you cross a permanent water crossing? Well, you do one of two things. You either swim or you build something that can raft you or boat you across. And so it is very likely that we haven't found any Homo erectus boats per se. It's very likely that Homo erectus possessed the cultural knowledge at least to innovate to build boats to be able to raft across open water. And then we've got this debate. Over when language first evolved. When we look at the language skills of apes, we find that the cognition for language is present in chimpanzees and gorillas. So that means that certainly our hominin ancestors would have been smart enough and had the intellectual capacity to utilize language, but they don't have the anatomy for spoken language. Homo erectus, though their language would not have sounded like ours, is starting to get the skeletal and kind of larynx anatomy, at least for a rudimentary spoken language. And really, when we're talking about some of the cultural exploits like boat building, like long distance cooperative hunting, language is an adaptive advantage. What does language do for us? It allows us to do something called cultural consolidation. That is, it allows us to build up a larger mass of cultural information so that we no longer have to directly experience the conditions and then trial and error figure out how to solve them. We are able to rely on predominantly folklore through oral traditions that teach us how to cope with adversity, to cope with conditions that we rarely experience. And so that cultural consolidation allows us to more readily innovate new solutions and allows a larger proportion of our population to be able to survive, let's say, weird climatic events, weather events, or even pushing into new. New areas. I mean, as Homo erectus leaves Africa, they're going more into temperate climates, which means they also probably built or fashioned some form of clothing. They would turn animal hides into clothing to be able to deal with colder temperatures. This ability to control fire also helps you in terms of staying warm at night. It also helps you in terms of staying safe at night. Homo erectus is the first hominin that no longer had to climb trees at night to be able to evade predators. When you keep a fire going all night, predators are much less likely to come and try to move into your encampment. So as we look at these Lamoquian to Oldowan to Acheulean tools of Homo erectus, what do you notice? Well, first off, they become smaller, right? That makes it much more easy to grip and means that we can start retouching them even more, and we've got firmer control. We're better able to control the movements of these tools. What else do we see? We see a much more marked cutting edge on these Acheulean tools when compared to Oldowan tools. Lamequian tools are hardly retouched at all. Oldowan tools typically only retouch one side. They get some sharpness and some force, but they're not really able to cut very well. These Acheulean tools could both penetrate hide. They could also cut hide, which becomes necessary when manufacturing clothing. And this then brings us to what we call the Pleistocene. Around 2 million years ago, or 2 million years before present, we start to see continental glaciers in the northern hemisphere. This marks the beginning of the Pleistocene. The Pleistocene doesn't involve continuous ice coverage. What it involves instead are periods of glaciation where the glaciers move farther south and have a farther reach, but also times when the glaciers retreated, or these warmer, what we call interglacial periods. So we've got this advance and retreat over much of Europe, over much of North America. Not only do we have alternating warm and cold phases, but we also have a scale and rapidity to the changes. There were at least 20 glacial interglacial cycles during the Pleistocene. We talk predominantly about the last three because it's not until the last three glacial periods where we start to see hominins make it into Europe. So, for the first 17 glacial periods, it has an effect on other animals and on plant life, but not as much of a market effect on humanity. It's with these last three glacial periods that it really starts to affect humans. One other thing that happens as we have the advance of the glaciers, this captures up a lot of the surface water of the earth in these frozen ice sheets. And so when water is captured in the frozen ice sheets, what happens to our shorelines? Well, we're experiencing the opposite of that right now, right? As we talk about global warming, global climate change, the melting of the sea ice, the retreat of the glaciers that we have left, we're talking about coastlines or sea levels that are rising, right? So the coastlines are retreating. Well, during glacial advance, the coastlines would advance. So when we think about kind of what's right off the shore at the point where the continents reach the ocean, right, where the landmass reaches the ocean. We've got this area called the continental shelf, where it's alternately exposed and covered by water with high tide and low tide. You can walk out on it some distance without going into really, really deep water. It's a shallow area. It's a warmer area where a lot of fish have nurseries, so where a lot of the spawning and reproduction of fish takes place. you've got marshes, you've got shellfish, you've got all sorts of things that occupy this continental shelf. Well, um, as per Finding Nemo, beyond that you have what's called the drop off. So that is the area where during glacial periods um, we would have had the coastline. The coastline would have started, or the ocean would have started at about the drop off. The continental shelf would have been exposed. In some areas of the world, like what's pictured here with Beringia, that means land bridges would have existed. So Beringia is not simply, or when we think about the Bering Land Bridge, it's not simply like a one-way bridge. Beringia as a landmass was exposed for thousands upon thousands of years and was inhabited for thousands upon thousands of years. So, as we think about the movement of modern Homo sapiens into North America, it wasn't a one-way deal where we crossed over and never came back. We continuously settled some of these areas like Beringia, and probably have an extensive archaeological record. Now, the problem with doing archaeology in Beringia is what? Well, I mean, it's underwater. And not only is it underwater, but that water is really, really, really cold. So it's not really an area that's conducive to studying archaeologically. Not only would this landmass Beringia have been exposed, but there's an area that's called Sahul, which includes Australia, New Zealand, etc., that would have been a much larger exposed landmass, which makes the open water crossing to get to Australia much less significance, much less developed. So it wouldn't have required quite as extensive boat travel or across the ocean travel to settle Australia. And so, just to demonstrate, 18,000 years ago, we were at the peak of our last period of glaciation. And so, here we're looking at the extreme northern areas, right? We're talking about continental ice over much of Siberia. Northern Europe, Northern Asia, and Northern North America. And this would have created then an area that would have been basically a continuous landmass where humans would have moved across. So this brings us to the point of what we call archaic Homo sapiens. There are other species of Homo sapiens besides ourselves, or other subspecies of Homo sapiens aside from ourselves. We are Homo sapiens sapiens, or anatomically modern Homo sapiens. Between about 850,000 years ago and roughly 28,000 years ago, we've got some specimens that we're not entirely sure whether they qualify as separate species or simply separate subspecies. We start with Homo heidelbergensis. Homo heidelbergensis is a transition fossil between what we consider Homo erectus and more advanced, full-fledged modern Homo sapiens. Some of the earliest members, say Homo heidelbergensis lived throughout Europe, Africa, and Asia between about 850 and 200,000 years ago. Made it to China, made it to Morocco, made it to Indonesia, made it to the Suffolk seacoast of the British Isles. So heidelbergensis was a human on the move. I mean, Homo erectus was already a human on the move, really our first hunter-gatherer. We've got a rich the reason it's called Homo heidelbergensis is because of an early fossil that was found near Heidelberg, Germany. But we've got a rich deposit of heidelbergensis fossils that come from Spain's Atapuerca Mountains. We've got flakes and stuff that are found on England's Suffolk seacoast. So Homo heidelbergensis reached northern Europe at least 700,000 years ago. We've got some footprints that are in danger of being lost that also show the movement of early humans into northern areas of Europe about 700,000 years ago. We've also got a cave complex in Terre Amata, France that shows that as early as 300,000 years ago, there were seasonal groups or patterns of movement that brought mobile foraging bands into the same areas repeatedly year after year. Archaic Homo sapiens encompass some of the earliest members of our species. We generally include Neanderthals and Denisovans in Archaic Homo sapiens, which would place them not as Homo neanderthalensis, but instead Homo sapiens neanderthalensis, or subspecies level designation. And they range from about 300,000 years ago to 28,000 years ago. We've got Neanderthals that lived in Western Europe that were presumably cold adaptive and have some of these very robust kind of hard knock life features. But we've also got um, Neanderthals that lived throughout the Middle East. We've got another sister group of Neanderthals, the Denisovans, that started moving into Asia and moving farther east as far back as 300,000 or 400,000 years ago, gave rise to modern day Melanesia. So at this period of time, we've got a lot of human groups on the move. A lot of human groups that we're not entirely sure whether we should classify them as species or subspecies. We've got interbreeding between many populations of archaic Homo sapiens. Neanderthals and other archaics have a brain size that's well within the range of modern humans. So they've got brains that are similar to ours. They've got modern postcranial skeletons. They lived during these second and third glacial periods. They were able to culturally cope with increasing environmental diversity and adversity. So looking back at this period, really from about 500,000 years ago to the present, you see the overlap of quite a number of populations of archaic Homo sapiens. We've got areas of the world in periods of time where we're seeing rapid diversification of Homo sapien fossils, where we're seeing overlap of multiple populations that have different features, where we're seeing interesting mixes that are markers of hybridization. And there was just a headline that came out very recently talking about a single female child fossil that represents hybridization between Neanderthals and Denisovans, even. So, a lot of interesting things going on evolutionarily.